More retaining walls fail from drainage problems than from structural inadequacy. The reason is simple physics. Water behind a wall creates hydrostatic pressure, the full weight of a column of water pushing horizontally against the wall. A 2m wall with fully saturated soil behind it experiences roughly double the lateral pressure compared to properly drained conditions. Most retaining walls are designed assuming the drainage system is working. If drainage fails, the wall sees loads it was never engineered for. This isn't a theoretical concern. In every retaining wall failure we've assessed, inadequate or failed drainage was a contributing factor in the majority of cases. The critical point: drainage isn't an optional extra. It's a structural requirement. A wall without proper drainage is an under-designed wall, regardless of how strong the structure itself is. A properly engineered retaining wall drainage system has 4 components. Each one serves a specific purpose, and removing any one of them compromises the entire system. A 100 mm perforated PVC pipe wrapped in a geotextile filter sock installed at the base of the wall behind the footing. This is the primary water collection system. It intercepts groundwater before it builds up pressure against the wall. Must be bedded in a 150 mm layer of 20 mm drainage gravel. Must fall at minimum 1 to 100 gradient, 1% fall, to the discharge point. Perforations face downward, common installation error. Many builders put them facing up. Must connect to a legal discharge point, stormwater, daylight outlet, or soak pit. Geotextile sock prevents fine soil particles from clogging the pipe. A 200 to 300 mm zone of free-draining 20 mm aggregate directly behind the wall, extending from the AG drain level to near ground surface. This creates a vertical drainage path, so water migrates downward to the AG drain rather than sitting against the wall face and building up pressure. Must use clean 20 mm aggregate with no fines, not crusher dust, not road base. Extends the full height of the wall. Minimum 200 mm thick, 300 mm preferred for walls over 1.5 m. Separated from retained soil by geotextile filter fabric. A non-woven geotextile membrane wrapped around the gravel blanket, separating it from the retained soil. Without it, fine soil particles migrate into the gravel and clog both the drainage blanket and the AG drain, a process called piping. Once the drainage system clogs, hydrostatic pressure builds and the wall's days are numbered. Non-woven geotextile is preferred over woven for filtration applications. Must be lapped at joints, minimum 300 mm overlap, to prevent soil migration at seams. Piping typically takes 2 to 5 years to render a drainage system ineffective. The wall doesn't fail immediately, but the clock is ticking. 50 to 75 mm PVC pipes passing through the wall face at 1.5, 3.0 m centers, angled slightly downward toward the front face. These are the secondary drainage path, a safety valve. If the AG drain becomes overwhelmed or partially blocked, weep holes allow water to escape through the wall rather than building up behind it. Should be visible on the front face of the wall. If you can't see weep holes, they may not be there. Typically installed at the base of the wall, 1 or 2 courses above ground level. Staining or water flow from weep holes is normal. It means they're working. Therefore, with proper soil water drainage done to retaining walls which minimizes the hydrostatic pressure on the wall, then the failure due to water pressure cannot occur. Bye-bye and thank you for watching. Till next time, subscribe for more.